Okay, well the last task we need to do for our probability lecture is to learn 3 statistical distributions that are modeled in Excel that solve some broad classes of business-related problems. So the first distribution we'll talk about is the binomial distribution. So what do we use the binomial distribution for? It's when you have a series of yes or no questions. Well, this applies to a lot of things in business. For example, if you have customers that enter your store, we can ask if they will actually purchase an item or not. That would be a yes or no question at the customer level. Did customer 1 purchase an item before leaving? Did customer 2 purchase an item before leaving? And so on. You could also ask, did a car that passed the restaurant stop in for lunch? Did the next car stop for lunch? There's lots of different yes or no questions that are going to be relevant to businesses, especially when aggregated. And so the binomial is good for that when you know the probability that the answer is yes. It doesn't matter how many times the answer's been yes in the past. That's an assumption of binomial. So what it can't do, it has to be a yes or no question. So to ask how much was spent by customers in the lunch rush can't really be answered as a yes or no. That would require a different model. The other assumption that's important for binomial is that the population from which you're asking these yes or no questions is significantly larger than the sample you're checking. So, for example, if you're thinking about whether or not cars stop in McDonald's for lunch, there's a very large population of cars traveling on the streets in La Crosse in any given year or day. And so whether or not one stops for lunch at McDonald's isn't going to have a huge impact on your overall expectations. But if you're trying to find, say, career prospects, and you have a pretty unique skill set, then the number of people competing with you for those positions may be small. And so even if there's, say, 8 candidates and 5 jobs, if one of the candidates gets a job, that reduces the number of jobs, but it also reduces the number of candidates. And so your chance each time to land it won't be necessarily 1/8 because you're 1 out of 8 candidates, but it might decrease as they file off into their various positions. So if the population is close in magnitude to the sample, then the binomial distribution may not be appropriate. So how do we use it? So binomial is written as binom.dist in Excel, and it asks 3 things. It asks to know the number of yeses. So again, this is a series of yes or no questions, so it's going to ask the number of yeses. How many times you tried to get a no or yes, how many times did you ask the question, and then the probability of yes or no. And then a flag, a true or false flag, with 1 being cumulative probability and 0 being the standard probability. And that means furthermore that if you set the flag to 1, to true, then if you put in 5 as the number of yeses you need, it will tell you the probability of getting 5 or less yeses. And so maybe you're interested in 5 or less, but you might have been interested in 5 or more, which would require you to do 4 or less. So there's some tricks there, but the basic setup is equals binomial, number of yeses, number of times you tried, probability. So let's give that a shot. So if I ask a question, what's the chance the stock market goes up 3 years out of 5? The chance of going up in any particular year is 55%. So if I go to my binomial model, I type binom dist. So it wants to know the number, so that number underscore s, that stands for number of successes. So we want to be successful 3 times out of 5. We're going to be going up 3 years out of 5. And let's say we do 3 years out of 5 or less. Or more, maybe. How about or more? So we just want to make sure we go up at least 3 times. If we go up 4 times or 5 times, that's fine. So the probability of going up is 55%. And if I put a 1 here, now I read that as 3 yeses out of 5, 55% or less. So 3 or less yeses. Now we wanted 3 or more yeses. So 3 or more yeses, the opposite of that is 2 or less. And then because we're taking complements now, we want to do 1 minus. So again, 3 or less would be written with a 35.551. This is now 2 or less, but because I've taken 1 minus, it's going to generate the opposite, which is 3 or more. So the chance that we get 3 or more is roughly 60%.